oldest known cliché, that, isn't it? Light dawns and the darkness is swept away. Maybe that's why all great scientific discoveries are always described as a kind of mystical, light dawning experience. Einstein is supposed to have thought of relativity in a dream he had about riding on a beam of light. When Darwin's theory of evolution hit him, he said, "The scales fell from my eyes." Gutenberg described the idea of the printing press as coming like a beam of light. Kekulé was daydreaming on a London bus when he saw atoms forming into molecules. And Newton said he got the idea of gravitational theory from a falling apple, and so on. All flashes of insight, so to speak, great moments of discovery. That's what's supposed to separate the geniuses from the rest of us slobs, that mystical experience, isn't it? And throughout history, each time it has happened, the condition of mankind has changed for the better in some way as we took one more step on the road to understanding. And with each of those steps, each addition to the body of knowledge, as you've seen in this series, our view of everything, of the universe and our place in it, has also changed. As the knowledge changed, we did. And if you look back as we have to the world of the past, we've come a tremendous way to our extraordinary high-tech world, full of innovation, of computers and laser beams and genetic engineering and artificial hearts. And above all, of fantastic power. 1,000 years ago, life was ruled by the mysterious and magical powers of nature. Then, with the fall of Spain to the Crusaders and the new knowledge they discovered there, the first hesitant steps were taken that would bring us to science and the exploration of the universe. In 1400, the Earth lay uncharted. Some even said it was flat. To the south lay regions of fire, and to the west, an endless ocean from which nobody ever returned. And then, in Florence, perspective geometry was rediscovered, and the world changed shape. Scale drawing gave people the ability to control objects at a distance because now they could measure them accurately. And that new ability laid down a scale for the universe that freed us to explore the unknown. Now we could give any spot anywhere a set of coordinates. It was no longer unknown. This spacecraft can only go into Earth orbit and return safely because of those coordinates, because we can now grid the planet in the sky. In the 15th century, the invention of printing took our memories away and gave us all standardized knowledge. Thanks to print, we have the know-how to fashion anything we want, and we live in a world of specialization and expertise where technology can make spaceships from 1 million interchangeable parts. Before the 16th century, we thought the sky was made of crystal spheres, that things moved up there because they somehow wanted to. Now we write the equations that make the heavens work. Where once we spoke of celestial beings and heavenly movers, we now talk about dynamics and trajectories. With those abilities, we can turn every aspect of nature into numbers, and then use those numbers to predict what will happen next with great precision. Here, in this Mission Control Operations Room, for instance, they can send a 75-ton space shuttle into a 200-mile high orbit, accurate to within inches. Until 250 years ago, we relied on the forces of nature as a source of power. Then, with the steam engine, came the ability to build and operate the most powerful machines in history, that today take us off the planet out into space. 200 years ago, modern medicine began. Today, we can monitor life even as it circles the Earth at 17,000 miles an hour. And at the beginning of this century, we found the tools to investigate the fundamental structure of the universe. Subatomic physics brought nuclear energy, it unraveled the secret of life, And through electronics, it has made knowledge more accessible than it has ever been before by putting it on a microchip. Thanks to science, it would appear, the way ahead lies only one way, onward and upward.
T-minus 10, 9, 8, 7. We have main ignition at 5.
'And yet, at any time in the past, people somehow managed without the benefit of spacecraft, with a knowledge of everything that was, to us, incomplete, wrong, but that was to them, true. They lived in worlds that were as certain of their facts as we are of ours, and that led them to do things that we would regard as totally alien. Like the event you're about to witness, you'll understand every word about to be spoken by people who lived only 300 years ago. But their truth was so different from ours that although you'll understand the words, they won't make sense.
Woman, stand up!
Beginning with the fact that decent, God-fearing people have spent days torturing this woman.
Now tell me, Agnes, do you know John Bell of Newtown?
Aye, sir.
Are you friendly to him?
No, no, sir.
Why are you not friendly to John Bell?
I don't recall just why now. We fell out.
And Janet Clark? Did you have hot words with her?
Aye, sir, I did.
Does John Bell have many cattle, Agnes?
He does, sir. A good many.
But not as many as before.
They took sick.
Would that be after your falling out, Agnes? 7 years ago.
Maybe. Sir, may I sit down?
And Janet Clark's horse. Did that also die of a sickness?
Aye.
Would that be 4 years ago, soon after you had the hot words with her? Did you not refuse to see the horse?
Sir, I didn't have cures for horses.
But you didn't cure John Bell's cattle.
He's a thief.
Oh, so 'tis true then. You threatened him.
No.
You threatened Janet Clark.
I didn't threaten.
But the animals took sick, woman. Did they not take sick and die?
They did.
Woman, I hear you spin well. Do the neighbours take thatch from your roof?
'Twas Janet Clark took my thatch.
And was not clay found in your hearth?
So they say.
Why is it that you spin so well? How do you explain your skill?
How can you see? How can you see?
You once meet a man of the lower ridge. Woman! I said, did you once meet a man near the lower bridge?
Sir, I don't remember.
But you were seen. Annie Cuthbertson saw you with a man in grey. Did you go with him?
It was a long time.
I said, did you go with him?
Maybe.
And you met him many times. Also by the round barn.
Oh, it was but a few times I went with...
I know who he was, woman! Annie Cuthbertson saw him. So, We must find the mark. Aye. We must find the mark.
The witnesses to this burning of a woman alive are not going to see what you'll see. For them, the witch is grateful for what they do. In the reality of 17th century Scotland, this was an entirely logical and rational thing to do, to torture and burn a witch in order to save her soul. This, for them, was an act of mercy. But if you're feeling good about the fact that we in the modern scientific world have a more objective, clear-sighted view of things than people who believed in witches, or any other weird version of what the universe was all about people had in the past, that they were in the dark compared with us. Well, if that's being in the dark, so are we. Let me show you how everybody sees their own witches, has their own structure for what reality is. And whatever you come up against, you make it fit that structure. Let me show you the simple stuff first. Look, see these two white bars, this one longer than the other? Well, it's not. They're the same. You made it longer because your brain decided it was further away. And look at this. It's a face, except it isn't. It's hollow. But hollow faces don't exist in your brain, so you can't see it hollow. You make it fit your theory of what it should be. Same here. Two triangles, three white dots. But you take away the dots, and the top triangle disappears. Your brain made that triangle. You alter reality to make it fit what you've decided it should be. And once you've made that decision, it's impossible to compromise with. Is this a duck or a rabbit? You see how it can't be both. Is this a young lady or an old hag? Here's the young lady's neck, chin, cheek, and eye looking away from you. Or here's the two eyes of the old hag and her great big nose and nostrils and a gash of a mouth. Now try seeing them both together. You can't, can you? There can only be one hypothesis that fits. Sometimes that hypothesis is so strong you'll see something that's not there. What, for instance, do you make of this? Are you seeing moving people with lights on them? Because what's on the screen is just a lot of dots. Or this. You only see the dog because you already know the shape. Without a structure, a theory for what's there, you don't see anything. Take this meaningless pattern. Or a cow. See it? You have to have some version of reality, whether it contains spotted dogs or cows or women that should be burnt. And science is the same. Without hypotheses, preconceptions about the world, how could you begin to research? Without theories about things, nature is just chaos. For things to make sense, you have to make up your mind about them in advance. Otherwise, you don't know where you are. Know what this is? It's a river delta from the air. And this? It's the next place we're going to in the program. The mental structure I was talking about, that has already made your mind up about what you're looking at now, and without which you wouldn't recognize anything, works at a far deeper level than just seeing. It provides a framework everything fits into. The structure evaluates, explains, organizes every experience you have, intellectual or physical. It says what the whole of reality is. It provides your beliefs, judgments, morals, ethics, values. And it also provides a rule book for the kind of questions you ask about the world, because it gives you the theory about how things are supposed to work. I want to show you what I mean by that, by showing you how the structure controls how science in particular progresses. Because science is supposed to be in some way independent of these things, isn't it? Objective, seeking and discovering the truth. But as you'll see, the truth is what the structure says it is. There is progress, change. But that's because the rules of the structure control investigation at every level until you get down to a bit of detail the structure can't handle. The bit of detail I'm going to get to at the end of all this. That bit. Remember that. In particular, remember those lines running parallel to each other. So the mental structure operates at every stage to control what you do. At the overall level, for instance, it tells you what the universe is. A good example of that originated here in Greece. Aristotle thought it up, and it seemed such common sense that it ruled all questioning for 2,000 years. His structure of the universe was like this: a series of concentric spheres carrying the sun, the moon, the planets, and the stars, all circling around the Earth at the center. You remember that medieval idea of the sun going around the Earth? Well, the church that promoted that idea lived in this. Now, you'll note that this structure is complete, closed, unchanging. In a universe like that, astronomers only watch the sky in order to refine this model as accurately as possible, and nothing else. Sometimes, when the universe isn't static like this one was, but changing, you can investigate it. But the investigation is still controlled by the way you think the universe you're living in changes. And the kind of thing you question in your investigation depends on what you think the mechanism of change actually does. Take the case of the 18th century financial idea that the economic market found a natural balance between supply and demand, and therefore the whole universe should be in balance. Gave us this stuff. Because when a German called Liebig went looking for balance in plant growth and found that plants get their carbon and nitrogen from the atmosphere, he burnt all the vegetation he could find. Then he looked at the ash to see what it was the plants needed they weren't getting from the air, which was minerals to balance their natural acidity. Put the right minerals in the ground, he said, and you'll boost crop yield without exhausting the soil. And because of the stuff from the air, you'll never upset the balance. Saved the 18th century from starvation with artificial fertilizer, thanks to a structure that said everything balanced. Whole areas of investigation can be off-limits when it looks as if the results might contradict the accepted view. Science can't rock any boats. I use the boat-rocking image deliberately because when Galileo's troubles started, down south with the Vatican, was when he was playing around with why things floated. It all began with ice floating in ponds, or in bowls, and after various experiments, Galileo came up with the not exactly earth-shattering idea that floating had to do with things being lighter than water or not. Lighter, the object would float. Not, it wouldn't. Harmless enough remark, you'd think. Aristotle had said that floating depended on whether or not the shape of the object penetrated the surface of the water. Like this. Same material, two different shapes. Round, penetrating the surface, goes to the bottom. Flat, not penetrating, stays afloat, just like flat ice. Well, Galileo sacked that idea as easily as I can, like this. You can't do that to ice. Okay, so Aristotle was wrong. What was so terrible about that? Well, you'll recall that the accepted view at the time was the way Aristotle's cosmic structure included the idea that everything in the universe had a proper place in the grand scheme of things. So, you doubted one bit of Aristotle, like what he said about floating, and you doubted all of him, because his was a package deal. Now, the proper place in the grand scheme of things for the powers that be was, for the powers that were, at the top of the heap, and there could be no doubt about that. Well, you get the point. Science came north for safety. Galileo's ideas were, so to speak, put on ice, and he himself under house arrest. Experimentation itself depends on what's official and what's not. Take, for instance, this example of nothing. The vacuum in a barometer. In 1660, somebody had claimed to have discovered it. A hole in reality, they would have called it. Aristotle, of course, said that it didn't exist, that the universe didn't have holes. So when an aristocrat English scientist called Robert Boyle started going through hoops to prove that the vacuum did exist, as advertised, you'd think, like Galileo, that the inevitable trouble with you-know-who would have turned out to be quite a shattering experience. But the English church supported a monarchy, and it needed a vacuum. A hole in reality was a place for angels and souls to go to. If it existed, they did. If they did, so did God and his authority, which was represented on earth by the church and the king. So it was a case of long live the vacuum. Not surprising that the first barometer was English, So, your view of the world dictates what you do down through every level of investigation, even down to the point where, during your research, it controls what you take to be reliable evidence. Around 1912, in England, fossil fragments were found, the brown bits, that went together in a reconstruction like this. Stained from ages in the ground, a human skull in an ape face. Several bits were missing. The jaw joints, and the chin among them. The teeth were worn the way human teeth get worn, and nearby were found flint tools and prehistoric animal bones. Dawn man, they call this. Now I'll do it again. Around 1912, somebody faked this lot. The stain was chemicals. The teeth were filed down, so were the flint tools, and the prehistoric animal bones had been collected from all over Africa. And the missing bits, the jaw joint and chin, would have revealed that the skull and the jaw didn't belong together. A con. But for 40 years, Piltdown Man was a scientific fact, because science was expecting to find the missing link between ape and man with a developed brain. This was such a clincher, the evidence wasn't questioned. But in 18th century pre-revolutionary France, the evidence for this was. See, peasants would tell scientists about these here stones falling from the sky, and the scientists would make this French sign. Science hadn't seen them, they didn't exist. As for the evidence of peasants, came the revolution with the peasants in charge. Suddenly their rustic references became vital astrophysical data. By 1803, there was a book on meteorites. By a scientist, of course. Just as well for science. Otherwise, what would they have made of this big hole I'm at the bottom of, here in the Arizona desert? It's called Meteor Crater. So you see how the structure, the view of things at the time, controls what science does at every level, from the cosmic questions about the whole universe, to what bits of that universe are worth investigating, to how far you let the questions take you, what experiments to do, what evidence you can and can't accept. And down at that detailed level, the control still operates, because it even tells you what instruments you should use. And of course, at this stage, you're looking for data to prove your theory, so you design the kind of instruments to find the kind of data you reckon you're going to find. The whole argument comes full circle when you get the raw data itself. Because it isn't raw data. It's what you plan to find from the start. This instrument, for instance, will find only one thing. How many inches across my forehead, between my ears, and so on. It's a 19th century craniological caliper, and it was built because they already decided that skull size and intelligence were related. For them, inches, the raw data, were brain power. That's when the myth of clever people having big heads started. Now, there's only one fly in all this ointment, and you've already guessed it. What about big heads that are stupid? That's where the whole system can lead to its own destruction, when some detail doesn't fit. That's when you see science hanging on like grim death to stop the rug being pulled out from under years of happy status quo. That's why I'm on an oil rig in the Gulf of Mexico. You see, back in 1912, the accepted view of the planet was that while geological ups and downs were okay throughout history, everything on Earth was in the same basic position as it had always been. And then a weatherman called Wegener said, I've been thinking, look how well South America and Africa fit. And isn't it funny how they have the same fossil animals up to a certain date, and then different animals? And these Scandinavian mountains, they're the same as the ones in Scotland and in North America. Maybe everything was all joined up once and then drifted apart. Well, by the time the geologists finished with Wegener, there was nothing left but the feathers. The continents don't fit exactly. The animals could have crossed over on temporary land bridges. And anyway, continents drifting in solid rock, do us a favor. So, for 40 years, Wegener was a dirty word. Then, in the 1950s, the magnetometer was invented. It identifies magnetic fields. Now, the Earth's got one. In fact, it's like a giant magnet. And rocks have traces of the Earth's magnetic field in them. As the magnetic field in the rock turns with it, you can see the needle reacting to the north-south variations in the field. Only if you looked at a rock sample drilled from the Earth, with the oldest rocks at the bottom and the youngest rocks at the top, about every 200,000 years, the rock magnetic field would reverse. First this way, then this way, then this way, then this way, and so on. Now, since the rocks got their magnetism from the Earth's magnetic field when they cooled and formed in the first place, that meant that the Earth's magnetic field was reversing about 5 times every million years. Now, remember that for a minute. In the 1960s, oceanographers discovered these 10,000-foot high ridges running down the seabed like that. Volcanic, hot. And to everybody's surprise, the ocean floor around them was very young, as rocks go. It looked as if molten rock was coming up at these ridges and spreading out on either side and hardening all the time. Now, one way to check was the magnetic state. If new rock was being made all the time parallel to those ridges, it should pick up those reversing magnetic fields I just mentioned in strips. Trouble was, as they moved around the ocean, all the magnetic mapping they were doing looked like this. Here's the average seabed magnetically, just a jumble. And then, right in mid-ocean, they found these. Giant strips of ocean floor on either side of the ridge, each strip magnetically opposite to the one before. You remember those mysterious lines I showed you in Greece? This was the survey area that revealed the mid-ocean strips. The second they saw these, they knew that Wegener had been right. The ridge volcanoes were making new ocean floor, and as that spread, it pushed the continents apart. Gradually, they arrived at where they are today, like this. As the ocean floor came up and pushed out and hit against the continents, it would be forced back down again. And the pressure where that happened would cause earthquakes. That's why this is an earthquake zone, for instance. And that's why I'm on an oil rig. As the continents drift and the seabed moves, formations buckle and form cavities that fill with oil. A detailed continental drift map will tell us where to look for more oil in a planet that is totally not what science said it was before Wegener. Today's version of the truth about the world, irreconcilable with the previous version.
So, you see how the only structure in the shifting, changing face of nature is the one we impose on it with our theories. Each one the latest version of what we call the truth. New structures, new versions of how the world works, only appear because of some bit of detail the old version couldn't accommodate that causes everything to change. In spite of what science would have us believe, that kind of switch doesn't happen because of science steadily and purposefully heading towards the truth, with one discovery somehow following another along the way as part of some grand plan. As you've seen, each structure in the past worked perfectly well. That's what the truth was for a while. And as for one discovery following another along the way, what way? Going where? The so-called voyage of discovery has as often as not made landfall for reasons little to do with the search for knowledge. Science, like all other human activities, is a product of what society at the time thinks is important. What science has done in the last few hundred years has been directed by that fact.
Earlier on, in the Middle Ages, the whole structure of Western experimental science happened almost unintentionally. At the time, science would have had no purpose. The church said the world around wasn't worth studying. So the new logic from Arab Spain was used to check holy writing for errors of faith, to strengthen belief. And it was looking at light with that end in mind that led one monk to discover how the sun made rainbows, experimentally, using glass balls and logic.
There are other ways of looking at the universe. Take just one that started at the same time as our Greek way did 2,500 years ago, but that, unlike our way, doesn't change the world. And yet, in some ways, Buddhism does just what science does. It explains how the universe works, and comforts you when it seems to fail, and is an integral part of everyday life. Buddhism gives the Nepalese a set of values and rules of conduct for every aspect of their life. The images and temples are constant reminders of their explanation of the universe and where you fit in the overall scheme. The explanation doesn't change because it's built around a view of life as a recurring cycle, like the cycle of the seasons bringing birth and rebirth every year. As in nature, there is no end, because at the moment of death, the life force returns to the universe to be used again in a different form. A kind of conservation of energy, we would say. And as the returning seasons remind the believers of the continuity of the universe as they see it, so too do all the instruments that keep them in daily contact with that universe. The opportunity to be in touch with the cosmos through prayer, driven upwards from the prayer wheels that are found in every corner of their lives, to be turned at every opportunity, a source of comfort, giving a sense of purpose to existence, as science aims to do for us. Buddhism, like science, explains the universe to its believers through the use of symbols. Where we invent laws of pressure and thermodynamics and gravity to account for the different ways in which the universe shows itself in action, Buddhism put it all in the care of gods and sub-gods, each responsible for a different aspect of existence, each explaining to the believer why that bit of existence does what it does. And in every community, like an encyclopedia of knowledge available to all, the Stupa Monument, a complete summary of the view, as well as a guide to its ultimate aim of understanding. Each of these levels represents one of the 13 stages of knowledge that lead to comprehension and enlightenment, to nirvana. In the monastery schools every community has, the basics are taught by repetition. Nature is subdivided, classified, named. As Einstein taught us, these monks teach their pupils that everything in life is relative, that there is no absolute reality in anything you observe, because it changes as you observe it, and so do you. As with us, some students, who remember enough of the 84,000 sayings of Buddha, pass tough exams and graduate to advanced study. They become monks. At this level, Buddhism takes on some of the same aspects as Western science. Progress depends on expressing yourself in the specialist vocabulary of the discipline. The ceremonies act as exercises in recalling an explanation of the universe that in its own way is as complete as that of science. Ultimately, this view of the universe is different from ours because it turns away from the world, believing that to investigate the constantly changing forms of everyday existence can only bring confusion. High in the Himalayas, the Buddhist view leads you to the understanding of the temporary nature of life, and that enlightenment can only come by leaving it behind. The final step in the expression of this view of the world lies in the practice of meditation, used to put the believer into direct contact with the universe itself, and to bring understanding that the only permanent reality is to be found not in the parts of existence, but in the whole. To become a true priest, meditation lasts 3 years, 3 months, and 3 days, 16 hours a day, and leads to total denial of self. This view of the universe, then, is no view. That is, there is nothing to see. There is no truth, only emptiness.
I'm not saying that we should all give up the life support science and technology that our rationalist way of doing things has given us and come here to the foot of Everest, reject the world, and meditate. Just that non-scientific views of the world like this aren't necessarily ignorant. In their own way, they explain the universe as completely as science does. And as you've seen from this series, all that science gives us is what their belief gives them: certainty. Only ours changes all the time. Theirs doesn't. As for the permanent values that are supposed to remain unchanged in spite of our changing knowledge, well, they change too. Once it was good to burn women, wrong to claim the earth went round the sun, logical to argue about angels on the head of a pin. The values change every time the universe changes, and that's every time we redefine a big enough bit of it, which we do all the time through the process of discovery that isn't discovery, just the invention of another version of how things are. And yet, in spite of that, we still go on believing that today's version of things is the only right one. Because, as you've learned from this series, we can only handle one way of seeing things at a time. We've never had systems that would let us do more than that. So we've always had to have conformity with the current view. Disagree with the church, and you were punished as a heretic. With the political system, as a revolutionary. With the scientific establishment, as a charlatan. With the educational system, as a failure. If you didn't fit the mold, you were rejected. But, ironically, the latest product of that way of doing things is a new instrument, a new system that, while it could make conformity more rigid, more totalitarian than ever before in history, could also blow everything wide open. Because with it, we could operate on the basis that values and standards and ethics and facts and truth all depend on what your view of the world is, and that there may be as many views of that as there are people. And with this capable of keeping a tally on those millions of opinions voiced electronically, we might be able to lift the limitations of conforming to any centralized representational form of government, originally invented because there was no way for everybody's voice to be heard. You might be able to give everybody unhindered, untested access to knowledge, because a computer would do the day-to-day work for which we once qualified the select few in an educational system originally designed for a world where only the few could be taught. You might end the regimentation of people living and working in vast, unmanageable cities, uniting them instead in an electronic community where the Himalayas and Manhattan were only a split second apart. You might, with that and much more, break the mold that has held us back since the beginning, in a future world that we would describe as balanced anarchy, and they will describe as an open society, tolerant of every view, aware that there is no single privileged way of doing things. Above all, able to do away with the greatest tragedy of our era, the centuries-old waste of human talent that we couldn't or wouldn't use. Utopia? Why? If, as I've said all along, the universe is, at any time, what you say it is, then say.
Next, find out the answers to those age-old questions on The Ascent of Man. It's TV Science Classics Weekend, next on the Science Channel.